The number e is one of the most important constants in mathematics. It can be defined in different ways, and one of them is that it is a limiting value of the sequence 1 plus 1 over n to the power n when n is an integer and increases without bound. That is, n is a positive integer that's getting larger and larger. The table shows values of 1 plus 1 over n to the power n for increasing values of n. You can see that the values of 1 plus 1 over n to the power n are increasing as well, and they seem to approach the number 2.7182. It is shown in advanced calculus that when n becomes larger and larger, the values of 1 plus 1 over n to the power n approach an irrational number that is close to 2.7182. That irrational number is called e, so this is the name of that number, and it is about 2.718281. The decimal representation for this irrational number, as for any irrational number, will not repeat nor end. Since e is a positive number and different than 1, then we can consider an exponential function with e as the base, that is, function f of x equal e to the power x. This function is called natural exponential function. The graph of this function will behave like the graph of any exponential function with the base greater than 1. The graph is going to be increasing and passing through the points negative 1, 1 over e, 0, 1, and 1 over e. It looks like the graph merges with the x-axis when x's are negative, less than negative 3, but this is not the case. You have to remember that for any exponential function, and therefore for function e to x, the values of e to x are always positive. So the graph is going to stay always above the x-axis. However, the values of e to x for x's less than negative 3 are so small that distinguishing between the graph of the function e to x and the x-axis is basically impossible. The exponential function, the natural exponential function, is very often used in calculus. So it is very important that you know how the graph of that function looks like. You should know what the points this function go through and what the properties this function have. For example, that there is a horizontal asymptote y equal 0 for that function, and the function is increasing very slowly at the beginning until it reaches x equals 0, and then increases rapidly when x is greater than 0.